Hello Internet, Zach here, and welcome back to Collecting the Elements. This is part 2 of the major lighting upgrade, where I'm going to install the high voltage power supplies that make the noble gases and a couple of other elements glow. This is an upgrade that I've been planning pretty much since I finished building the table, realizing that there are a lot of gases that are just transparent, and hanging an ampoule full of xenon or krypton or oxygen on the table is just going to look like an empty glass vial, and that's not a whole lot of fun. And who's going to believe me that there's really krypton in there if it just looks like it's full of air or vacuum or could be anything? So I deliberately sealed the gases under low enough pressure that with a bit of high voltage excitation, they'd light up. And I've wanted them to be able to do that while hanging in the table. And it's taken me until now to finally get around to that. So you've probably noticed the P-block has been glitching out quite a bit. It worked perfectly for the first couple of days after I installed it, but Miss Kitty here, she likes to climb on things and knock the circuit boards over and all of that. I guess you don't want to be in the video, do you? No? No? You don't want to be in the video? No? Ooh, vicious. Okay. Anyway, after Annabelle attacked this a number of times, it started glitching. So, it needs some repairs. I'll get to them eventually. So, from eBay, I acquired some of these cold cathode fluorescent lamp inverters. I was supposed to have 12 of them by now, but one of the sellers was a scammer and only sent me 5 when I ordered 10. I'm still working that out. So anyway, these are the guts of one of those. I'll show you how I get the guts and make some small modifications to make this do what I want it to do. These normally have capacitors in them to limit the current, and since I'm capacitively coupling the high voltage into the gas samples, I don't need that capacitor because I'm basically already making one. Here's a tube full of low pressure helium gas, glowing with the capacitors in the way, limiting the current. This is the same tube full of low pressure helium gas, with the current limiting capacitors disabled. So, let's pry this open. And inside here, a circuit board covered in some gummy, plasticky stuff. There are the current limiting capacitors I'm talking about. Those are going to be coming off the circuit board. Alright, I won't be needing these connectors anymore, so I'm going to unsolder these. And I won't need these capacitors either, so I'm going to unsolder those. Alright, 2 new high voltage output leads without any current limiting capacitors in the way. The hole for the bottom electrode should be about here, and the hole for the top electrode about there. Just a good old push pin. Okay, these are the electrodes. They're made of braided copper wire. And then I have a thinner piece of solid copper wire wrapped around the braided ends. And the gas samples just slip right into these. Now, this is the tricky part. Because, yeah, the electrodes are enough to hold the gas sample securely in place now, with the little hangy hook as a bit of extra backup. Here we are on the back of the table, and these are the wires coming from the electrodes. And this is a modified CCFL inverter. And I'm just going to hook these wires over those wires and twist them together. I'm going to leave that ragged for now because I want to test that it works first. Okay, underneath the table, turning the light off, and the argon sample's glowing nicely. So I can make the connection more permanent now. Alright. Now that I've confirmed this works, the next step is to hot glue this inverter board down. So yeah, now I just need to repeat this process a bunch of times. little side note on how sulfur is going to need a little bit of help. Most of the element samples will glow quite easily just by putting 2 electrodes on them. This, for example, is an extra large vial of hydrogen that I keep around for testing purposes. If I swap this out for sulfur, nothing happens. Sometimes there you go. There it goes. Sometimes if I give it a little poke, it'll start lighting up. Watch, now that it's been lit, it might, yeah, it turns back on. But for some reason, sulfur can be hard to start sometimes. Anyway, the idea is that I have a wire down here, like so, that makes the sulfur easier to start. Okay, so here's the sulfur with its startup helper wire. Super important step, testing the power supplies, making sure they work. So it's oxygen lighting up. Helium is good. Argon. Argon's good. Krypton. Krypton's good. Yes, xenon glows. And iodine. So this here is a little control board. It's just a shift register and some power transistors, all connected together to switch these various inverters on and off. So I'm going to put this back here roughly between chlorine and sulfur, and then start connecting all these wires to the power transistors. It'll be a lot more fun after I get the glitching sorted out. But they do glow.